Now we've looked at categorical and numerical data types, but I told you there was a second way to classify data types, and that is to see them as either being discrete or continuous. Let's start off with discrete data types. Now a discrete data type contains values that have a definite minimum size. They cannot be further subdivided. A classical example is just the roll of a die. Now, if it's a 6-sided die, it can land either with 1, 2, 3, 4, 5, or 6 face up. It cannot land with 1.5 up. So that is a discrete value. Those are discrete values. The set of all the possibilities are finite. I can count them. 1, 2, 3, 4, 5, 6. Now, I want to caution you against two variables. One is money and the other one is time. Now, in most currencies, we have a minimum currency value, 1 cent, 1 penny, whatever it is. We can't have a quarter, a half, or eighth, or a 16th. That's not really true, though. If you think about large institutions working with large amounts of money, if you took some percentage value, you can run into many decimal values, and you can't throw all of those away because you'll be throwing a lot of money away. The same goes for time. We could say that 1 second is the minimum value, but you can certainly subdivide, make smaller, make smaller, make smaller. So specifically money, even though it feels intuitive to call money discrete, a discrete data type, it really is a continuous data type. Now, the continuous data type, there the set of possible values are really infinite. I can always subdivide them, make them smaller, divide them in two, go deeper, get more and more decimal values. Now, it's not always so practical though, so we don't really want to be too pedantic as to what really defines a continuous data type. We want to be slightly practical about it. Let's look at systolic blood pressure. If we had a blood pressure cuff and it gave us a value of 120 millimeters of mercury, but I can have a better cuff that can tell me it's 120.5. What theoretically I could have an even better piece of equipment and it can tell me 120.5555673254. That really just depends on how good my piece of apparatus is. So systolic blood pressure for us will be a continuous data type, although practical use we're always ever going to use integer values. If we look at white cell count, we might have a white cell count of 9.9 times 10 to the power 9 per liter. Now you might tell me, well, there is an absolute minimum. I can't count them because I can only go down to 1 cell. I can't have half a cell. But under these circumstances, we're dealing with such large numbers. Something to the power 9 is such a large number, but that for all practical purposes and for mathematical purposes, this is a continuous data type. So there you have it. All sorts of ways to classify and categorize our data points, and the reason why we're doing it is that we have statistical analysis for all of these different types.